Hi guys, genuine question. How familiar are you with the following concepts? Coulomb's law, the principle of charge quantization, and the charge of an elementary particle. So these concepts and a few others I'm going to cover, and we're going to use these concepts to answer the following questions. So stay tuned. Two identical metal spheres A and B are suspended on long silk threads as shown in the diagram below. The spheres carry charges plus 6 nanocoulomb and negative 2 nanocoulomb respectively. So the first question states, or the first question reads, state the principle of charge quantization. So the principle of charge quantization states that the charge on an object is a multiple integer of the charge of an elementary particle. So to understand this principle, we need to look at the formula for charge quantization, and the formula is represented by Q is equals to N times QE. So QE represents the charge of an elementary particle, and this could be an electron or a proton, and N stands for the number of these particles or these elementary particles that forms the net charge on the object. Now suppose you've got a sphere with only one electron. That means the net charge Q will be 1 times the charge of an elementary particle. In this case it would be an electron, so that's minus 1,6 times 10 to the power of negative 19. So this here is the charge of an elementary particle called an electron. Now suppose you were to introduce another electron. That means the net charge would then be 2 times that of the charge of an elementary particle. So it means that the net charge would then be the number of electrons multiplied by the charge of an elementary particle. So N can be any integer depending on how many electrons are on the object. So the next question says, which sphere A or B has excess electrons? Now this word excess here just simply means additional or extra electrons. So when paying attention to the two spheres here, you can see that this sphere B has a net negative charge. So it means it has additional electrons, it has extra electrons, but this one has a net positive charge. So this means that this one has a deficit, it needs electrons. So the answer to that question would be B, because the net charge is negative, that means it has extra electrons. So the next question says, calculate the number of excess electrons on the sphere identified in question 5.2. So this is where the principle of charge quantization formula comes in. The net charge on sphere B is equals to the number of electrons on the sphere multiplied by the charge of an electron. Let's use QE. You can also use E in the formula. So we're going to use QE. QE stands for the charge of an electron, of one electron. So QB is negative 2 nanocoulomb. So nano here stands for times 10 to the power of negative 9. So it's negative 2 times 10 to the power of negative 9 coulomb is equals to the number of electrons times the charge of one electron, which is negative 1,6 times 10 to the power of negative 19 coulomb. So now we're looking for N, so you can divide throughout by negative 1,6 times 10 to the power of negative 19. And on this side as well, negative 1,6 times 10 to the power of negative 19. So these cancel out. So it means that n should be equals to, so therefore n is 1,25 times 10 to the power of 10 electrons. Guys, just a disclaimer, in the principle of charge quantization formula, we use the charge, the elementary particle of interest is the electron, hence the E, because the only particles that's moving between the spheres are the electrons. So that's why I've used an E here, and that's why there's a negative here to indicate that we are working with an electron. Remember, an electron has a negative charge. So the next question says, the spheres are brought into contact and then separated. So the first question, state the principle of conservation of charge. So the principle of conservation of charge states that the net charge of any isolated system remains constant during any physical process. Now what this means is that if you have a closed system like this, a closed system means that whatever's in the system cannot be influenced by external factors or things on the outside. Now the net charge within a closed system remains constant. So it means electrons are just transferred within the system and nothing gets gained or lost within the system. So the net charge remains constant. And physical processes means that when these spheres touch each other or when they rub on each other, electrons are being shared or transferred from one to the other, and the net charge will always remain constant. There's no way that the charge will be lost to the system or the system gains more charge, because the system is an isolated system. So the next question says, which sphere gains electrons? Gains electrons when the two spheres come into contact. Now you can see, we saw earlier on that sphere B has an excess of electrons and sphere A has a deficit. So when the two spheres make contact, the excess electrons on this sphere gets transferred to sphere A. So sphere A is the one that gains electrons. Last question says, calculate how many electrons are transferred from one sphere to the other when they come into contact. How many electrons are transferred from one sphere to the other when they come into contact? So to solve this question, there's a 3-step solution that we need to follow. So after the spheres have made contact, you can calculate the charge on each sphere, the new charge, by using Coulomb's law. Once you figured out the charge on each sphere after they've made contact, then you can figure out from that the charge gained and the number of electrons. So I'm just going to do a visual representation of what I mean. So this is before they've made contact, and this is after they've made contact. So these balls A and B is after they've made contact. So once the balls have touched, you can calculate the charge on each sphere by using Coulomb's law. So let's do the first one. So you can work out the new charge. You can say Q new on each sphere is equals to the charge of sphere A plus the charge of sphere B over 2. and the charge of sphere A is 6 nanocoulomb plus negative 2 nanocoulomb all over 2, and this here is 6 minus 2 is 4 nanocoulomb over 2, which is 2 nanocoulomb. So each sphere will have a positive charge of 2 nanocoulomb after the metal spheres have made contact. Now from that we can work out the charge gained. Remember, when these two spheres make contact, electrons are transferred. So you can see that from 6 to 2, electrons were gained because it's gaining negative charge. So 6 will go down, and it went down to 2. So now we can work out the charge gained. So the charge gained, let me use Q. So the charge gained, I'm going to use G here. Let me use a small g. The charge gained is equals to Q final minus Q initial. So the final charge is 2 nanocoulomb minus the initial, or the original charge was 6 nanocoulomb. So this here is negative 4 nanocoulomb. And this just confirms that the charge gained is negative nanocoulomb. So it just tells us that sphere B transferred a lot of electrons to sphere A because it dropped from 6 to 2. So it gained a net charge of negative 4 nanocoulomb. So from this we can work out the number of electrons by using the principle of charge quantization. So we can say Q gained, let me work this side. Q gained is equals to N multiplied by the charge of an electron, QE, and the Q gained is negative 4 nano is times 10 to the power of negative 9 coulomb is equals to N times the charge of an electron, which is 1,6 times 10 to the power of negative 19. This has to be negative because it's an electron. So you can divide throughout by negative 1,6 times 10 to the power of negative 19. And likewise this side, negative 1,6 times 10 to the power of negative 19. Therefore, N is equals to 2,5 times 10 to the power of 10 electrons. So guys, I hope this video was helpful. If you have any doubts or questions or something wasn't clear to you, please let me know in the comment section. I will answer your questions. And thank you for watching. I'll see you guys in the next one.